What I want to do in this walkthrough is just give you an idea of working with the Mongo uh, shell, the Mongo command line. I'm going to go over here to my terminal window. I've already downloaded Mongo. You can get the community edition. When I start Mongo up, I start the Mongo daemon. I'm on a Mac, all right, but it works similarly in different places. As you can see, the command that you execute. I'm executing MongoD. Trying to highlight it here. MongoD-db path dot. Why do you use a db path option? That just indicates where the default root directory is for where Mongo will find its file storage for what it organizes the database files. It has a default directory that it uses on your system. If you want to change that, you use a db path, and you can use a relative path or an absolute path. I use the relative path because I'm in my opt MongoDB directory. That's where I installed. And over here, you can see I'm in the opt MongoDB data DB. It's always going to look for the subdirectories data DB underneath wherever the DB path is. And then you see it has all these files in here. Now these files are completely internal to Mongo. That's what Mongo keeps as its way of organizing the various things that are in your database at any given point in time. No reason for you to have to go in here. Obviously, you don't want to mess with this kind of stuff. You'll mess up your database. But just giving an idea of what Mongo does. And obviously, you can look at the command line or the online documentation for starting it up for the command line, or you can use an automated tool for doing so. What I really wanted to talk about, though, was the Mongo shell and the ability to import. So before I go into, well, actually, why don't I go into the Mongo shell? I'm going to create another. The Mongo shell is simply Mongo. All right, so MongoD is the daemons, that's the server. Mongo is the command line client. It's like going into a MySQL command line client. So here's the Mongo shell, gives me some startup information, and let's see what databases I have. I can do show databases or show DBs. Either one will. Let's do show DB since I'm having a hard time writing out show databases. I have three databases in here. A couple of these you get by default. And I want to bring a database in. Now in the directory with your data sets in the sample code, there's a file called primer-dataset.json, and I have it loaded here in my brackets. It's a bunch of addresses of restaurants in New York City boroughs, and it actually goes on and on and on. There's 25,000 some odd of these databases. So I want entries, I should say. And each one of these individual JSON objects, if you will, is considered a document, all right, according to JSON. So I want to bring these documents in. Now the way documents are organized in Mongo according to collection, I need a database. Within a database, I need collections. Within collections, I have documents. So if I go back to whoops, I'm in the wrong one. There it is. This is the Mongo import command. It indicates what I want to name the database, what I want to name the collection that I want to put all the documents that are in this JSON file. Mongo import has a variety of options. It also can import existing BSON files, which is technically the format that Mongo uses. Here I'm doing plain old JSON, as you saw from brackets. So I'm indicating the database. That database will be created. I'm indicating the collection. That collection will be created. And then I'm indicating what file to import from. So this should work. Let's see. Comes back, imported 25,359 documents. That's how many we had over here on the bracket side. So I'll minimize that. And let's go back into our command line. Which one was my command line? Here it was. Let's do show DBs again. Now primer shows up because I just did the import from it. I want to indicate that I want to use primer as my default database. So I switch the database to primer. And now that I'm in there, I can do show collections. Oh, sorry, I can't. Oh, well, I should probably type it right if I want it to show. All right, that helps. There's main, okay. I'm in the database, I'm in the context because I used it. I have the collections of main. What if I wanted to take a look at the data that's inside there, right? So I do DB now. No matter what database you're using, you use the handle DB to indicate in the present context, which is primer. I want to do a DB dot name of my collection dot now I want to execute some kind of query. So at this point, think of that collection as like a table with a set of rows. We talked about that briefly as a rough analogy, not a great analogy, but a rough analogy. And I just want to output everything. Now, if I did that on a table in a SQL database, I would do a select star from main, for example. Here I do a db main.find, right? And I'm not specifying any query on here or anything else. So I'm going to get, wow, I get a whole bunch of stuff, and it doesn't even look that pretty, right? It's not indented or anything, and so forth. So I can keep. Let me erase this. I think you're getting cut off a little bit. Type by T, more stuff comes out. Now, what if I wanted to show up, for example, I want to see how many things got outputted. I can do a count on here, for example, and it tells me. So that's the same thing as doing a count star, right, in our select statement. But what if I want to show these results a little bit more elegantly? There is a built-in pretty printer with a dot pretty. All right, and it starts showing these things a little bit more elegantly. Now, I don't want to scroll through 25,000 some out of these things. What if I want to go ahead and actually execute some kind of query on this? The query syntax in Find, so actually over here I have the web page up. You can go to docs.mondodb.com. You can also download MongoDB from there. Under the docs, they have the manual, and this is the manual page for the shell-oriented DB collection.find that we're executing. It actually takes two optional parameters. We're not including either one, but the first one will be a query, and the second one will be a projection, right? The query is like your where clause in a select query on a relational database. Your projection is where you list out the attributes and so forth. And obviously our from is actually built into what collection and what we're the find on, but basically what collection we're going to. So that's kind of how you can roughly map a DB collection.find with its parameters onto a select projection from collection where query type of thing. But again, we're using a document-centric model, so the queries aren't going to look the same, the projections aren't going to look the same, and it's not tabular and row-oriented. But that gives us some mental mapping, if you will. So let's go back and execute a few queries, right? So let's take a look. Look up above. You can see the kind of things, well, we saw it over in brackets, the kind of things that come with each document that's in this database. So let's go find all these restaurants. One of the things is the borough of Brooklyn. So if I want to specify a query as the first parameter, I would have to open a query itself is a mini JSON document, and I want the borough, if I can spell borough correctly, to be Brooklyn. I got cousins in Brooklyn, so I'm going to say Brooklyn. Great restaurants, great delis there, right? Comes back. Now I'm getting all the ones filtered. You can see borough up there. It says Brooklyn type of thing. So, and then on top of that, you see things like cuisine, right? We see cuisine Italian. So if I wanted to do the equivalent of an and, I would just comma separated the things in this query document, and I would say cuisine. If I again spell it right, is Italian. All right, and I get back the Italian ones. Again, I could even get a count instead of a pretty print of everything. I can find out how many things are actually matching that query. 192 of those 25,000, what was it, 359 documents are in Brooklyn and serve Italian cuisine, right? So we got a lot of restaurants in this database. But believe me, in Brooklyn, there's that many Italian restaurants. I believe it. What about some of the structure? We see an address here that has a complex structure. We see grades. These are embedded, right? These are documents within that document structure. So what if I want to say get all the, I want to get the specific one with a building ID. We see 4220 there. How would I get something that's embedded like that? Well, I use a dot syntax, right? So I want to say the address, because that's the outer attribute up there. And then the first attribute embedded in the embedded document is building. So address.building, and then I'll say 4220. Oh, and I had a fat finger there. Again, it's probably getting cut off. Oh, there we go. That's better. I put a semicolon here instead of the colon that I need. right? Oh, I was still doing a count, so I got one back because I'm still doing a count. Let's go back to doing a pretty print on that, and there you go. I get that one restaurant back. That is a building ID of 4220. So that's an example of querying into a nested part. You can also query using expressions. There's a a big number of expressions. I'm not going to go into all the syntax. Again, that reference page will have examples of that. There's actually a good cheat sheets out there on all the different expressions that you can write, just like you can do in a where clause, right? They use kind of a $ syntax on those. So for example, if I want to find that 4220, but let's say I find it by saying I'm looking for a restaurant whose building number is, and again, notice I'm opening an expression here. That's why I use the left curly brace, and I'm going to say I want it to be $LT less than. We're going to make it obvious here, 4221, and greater than $GT of 4219, right? So that gives us 4220. Now I need to close my curly braces properly, and I get back the same one again, right? But that's this syntax up here gives me that nesting of both into an embedded document and an expression on that field in that embedded document that uses an and of a less than and a greater than. Okay, so just give you a simple example of the kinds of different things that you can do with queries. Obviously, there's a lot more. It's as expressive as you would expect. You just have to do some kind of mental translation from what you're used to in SQL onto these fine kind of queries on the command line, and then we'll see kind of a relatively similar thing when we embed this inside of code in Java in the next walkthrough. What other things you can do? So I have all this, and let me go back to, in fact, let me just go back up. What's nice is it's got bash shell type syntax, so I can go back to, for example, our cuisine in Italian, and we had 192 of these, remember. Maybe I don't want to show all this information. I want to do now I want to list attributes. I want to do the projection, as we know from relational algebra. So I can go in here and use that second argument, right? I was using only the first argument, the query. Now I want to do a second argument, which is the projection. The projection is also going to be a document, and let's say I want to get the name. Now, because JSON wants those name value pairs, it kind of uses a 0 and 1 true false syntax, kind of like old C programs. So I want to say I want to include the name down there of the restaurant, and I'm going to and it with, I'm going to show the address. I want the name and the address of where these restaurants are that are Italian and in Brooklyn. All right, so I have that. It's a nested one again, so I got to close that expression, and now I get just the address and name. But wait a minute, I also show this underscore ID thing here with an object ID. Mongo is going to take each document and create an object identifier internal to it. So effectively, you kind of already have a primary key internally, if you will, assigned to these objects. But that, that wasn't in our JSON. That was automatically done by Mongo. That's what it's going to do. And that's kind of polluting my output here. So I can also filter out attributes that I want to show by using the opposite logic. So I can do the underscore ID colon, and we're using 0 and 1 syntax, so false would be 0. Okay, and there you go. Now I just have the name and the address. Notice how they're still coming out in the order that they are in the document. I didn't reverse the order, even though I reversed them in the projection. But either way, I'm getting the name and address out as I desire. So there's some very simple things that you do maybe used to doing from a SQL prompt perspective, equivalents of tables and rows and doing simple select queries on things. But again, we have the notion of a navigational API for documents and collections inside of Mongo, and our queries are going to be navigationally oriented with those kinds of expressions built in with JSON documents, and our projections as well are going to be small JSON documents that indicate what attributes or what fields we want to include in the result. So that's our brief overview of using the Mongo shell. Get in here, play around with it, and then it becomes second nature, just like working with a SQL database.